So we are the Center for Renewable Energy. Big change. But this is the picture of Manton Dam, which some of you might know. We have hydroelectricity generating at the site, which is a result of our collaboration with Power and Water, just to let you guys know. Anyway, so let me introduce our small research team. We are multidisciplinary. So the first one, we have Mirza, which is our research associate. He is also our computer specialist, technical analyst, our admin person, and he works in Power and Water part-time as well. So, and now he's on leave, so that's why. We have Jeremy, who have a physics background, who is looking at energy efficiency projects. Myself, Ken, I'm an engineer background in computer science and mechanical engineering. And we have Edward, who unfortunately couldn't join us today, who is an expert in buildings, architectures, and civil in general. So some of our main projects, as you can see, the first one is the funding from ARENA, which is my project looking at off-grid solar power systems. So we are looking at T3, Lake Nash, Kaukarinji communities, and this funding will be expiring this year. The second one, which is funded by the Department of Industry, is the Manimac Energy Efficiency Project for 3 years. Smart Cooling in the Tropics, which is funded by them as well, and the partners are CoolMod as well as Power and Water. The fourth one, which is the Energy Efficiency of Houses. This is funded by the Defence Housing Australia, where we look at how to best design houses, and this is actually a PhD project, which will be presented by Shahida later. And the good news, we are actually approved to be the technical advisory panel for solar hot water systems. So now we are a certified auditor, and we'll be getting jobs on solar hot water systems for the next 3 years, and we'll be auditing it, approving, hopefully, and so on. This is for the whole of Australia. And lastly is the solar roofing testing facility, which I'm going to show you guys later. So one of the case studies as mentioned is this facility. This project is a joint collaboration with the industry and CDU. So this facility is actually located in Ping 3, so you can guys go and see. So what we want to look at is how the environmental effects in the tropical climate effects on the solar panels itself. For example, water, cell color, buckling, because most of the solar panels are all lab tested. So people normally refer to their data sheet and look at, oh, this is the performance we're expecting, and so on and so forth. But through our experience, this is not the case, especially in the Northern Territory. So what we do is we put it out for over a year, over the wet season, the dry season. We take pictures, we look at dust, bird droppings, bat droppings, whatever droppings, just droppings in general, which some gets washed in the morning and some just stay there throughout the whole year. I have no idea why. And it's hard to clean them. And this actually affects the performance of these solar cells. The next project, which we are very fortunate today to be joined by Mr. Sam Latz. He is a project director for Power and Water, and he'll be here to talk about one of our collaborative projects.
So I'm not a CDU employee, Power and Water, and probably one of the few people here who haven't got any postgraduate qualifications. Anyone else here who hasn't got any postgraduate qualifications? One or two of us maybe. And also one of those solution-focused people who's more interested in how the research can inform future policy. What's the tie-in? I've heard lots of very interesting stuff about environmental science, fantastic stuff there. Very interested in the practical applications of those things. The tie-in for us obviously is carbon. And the funding that has got us here today is from the Australian Government's Low Income Energy Efficiency Program. And there's two projects that CDU are involved in there through CRE. Mine, if you like, the Manimac project, and also the CoolMod project. Power and Water's focus is on reducing costs to government, basically, providing services in remote areas, and I guess Coolmob's focus is on environmental benefits. But the tie-in there is reducing carbon emissions. So, and that all came out of policy on carbon, obviously, which we're still getting funded for. That's great. Off we go. This project is running in East Arnhem Land, looking at energy efficient appliances and behaviour change. The research here is both looking at the effects of those appliances in terms of reducing energy consumption, but also the evaluating the behaviour change components. And we're fortunate in having a team across CDU, obviously starting from our friends at RIEL, and looking at the energy, the hard data, if you like, energy consumption, the effects of various trials. We don't use the word interventions. Trials in those Indigenous communities, but also working across the whole university on the how to effectively work with local communities to conduct behavioural research. And Dr. Petra Bergelt is doing a great job of joining the dots across the university on that side of it. Yeah, so that's a short review. 3-year project. It's a $12 million project all up, but government is very interested in evaluating that, and just this week they're telling us the real focus now is on how these projects can produce information that can inform the next budget round, basically leading to next May. So yes, we're very, very focused now on not just achieving our milestones, but actually producing evaluations that can inform our policies.
And I'm working on the other LEAP project. This is the Smart Cooling in the Tropics. So this program is being led by Coolmob of ECNT. And this project is focused in the Darwin area, so in urban and suburban areas. And it's called Smart Cooling because the main focus is just on the cooling parameters of households. So essentially reducing air conditioner use in Darwin for the most part. And so project officers from Coolmob, they go to people's houses, they give them energy audits, and then they make a recommendation for different sorts of treatments. And most of the treatments are focused around increasing airflow and decreasing solar heat gain to a house. And by doing that, you hope to reduce the reliance on air conditioning usage. And so I guess the main goal of this project is to figure out the best way to keep people comfortable, but use the least amount of energy to do so. So that's basically that project. Our future plans are to engage research, educational, institutional entities in Southeast Asia. So one of us will be attending a workshop in Jakarta to try to promote collaboration with Indonesian entities over there. And we're doing a lot on urban design, we're doing a lot of projects that can, and the details from which will be able to help us improve urban design in the tropical environment that we live in. And then apply for some ARENA funding to increase renewable energy uptake in the Northern Territory, especially with regards to the renewable energy target, and further our collaboration with the clean energy regulators. Now that we've started doing the solar hot water heating systems, the auditing, hopefully expand that in the future. And now I'll hand it over to Chiquita to talk about postgraduate work.
Photovoltaic diesel power systems. His main research objectives are to develop novel control methodologies and assess the effects of high penetration photovoltaic systems in remote area power applications. And Catherine Matthews, she's doing her PhD project on energy futures in remote Australia. And her main objectives are to identify how existing livelihood and livelihood planning in remote Aboriginal communities is shaped by the current state of energy provision, and identify pathways for improving remote energy provision. And my research project is on energy efficiency of houses and best practice urban design in the top end. This project is running in partnership with Defence Housing Association, Investor Land and Power and Water Corporation. And my main objectives is to assess the Breeze Muirhead subdivision design and how it impacts thermal comfort and energy efficiency of households living in this area, and also to develop recommendations for subdivision and housing design which would provide the optimum comfort and energy performance in hot and humid tropics. Thank you.